So question 4 is kind of a weird one, but I really like it. It says a wheel of radius r rotates making f revolutions per second. The quantity f is known as the frequency of the motion. Show that 1 over frequency is the time to complete one revolution, also called the period of the motion. Show that the centripetal acceleration of a point at the rim of the wheel is then a 4 pi squared r f squared. So it's kind of weird to set up, but if we just think about it, this is our wheel, right? And it has some radius r. So first what it says is f is essentially the revolutions per second, right? So let's write it as revolutions per second. And then when it says the quantity f is known as the frequency, show that 1 over f is the time to complete one revolution. So 1 over f then would be 1 divided by revolutions divided by seconds. And your math teacher wouldn't like this, right? We have a fraction within a fraction. So instead of dividing by this, we're going to multiply by the reciprocal. So that's the same as 1 times seconds divided by revolutions, which is simply just seconds over revolutions. So what this is the number of seconds per revolution, or that is known as the t, or which is called the period. Okay, so how much time does it take to complete one revolution? That is 1 over my frequency. So there's this relationship of 1 over frequency equals period. Second part of the problem says, show that the centripetal acceleration of a point at the rim of the wheel is this value, right? So if we're taking some object here, right, and as it's rotating, what's the acceleration? We know the acceleration is towards the center, right? But let's prove that it's this 4 pi squared r of f squared. So acceleration centripetal is v squared over r. And let's just do big R there. V squared is going to be my, remember that v is my distance divided by my time. So that's 2 pi r over t, and that value squared divided by big R. This is big R here. So let's write this out. This is just algebra now and just seeing how this all works together. But we have 4 pi squared r squared over t squared over r. So again, our math teacher doesn't like this setup here. So instead of dividing by this r, we're going to multiply by the reciprocal. So 4 pi squared r squared over t squared times 1 over r, right? So with that, we can actually cancel out the r squared with that r. And we're left with the acceleration centripetal is 4 pi squared r over t squared. So what we know, based on what we showed up here, is that t, or the time it takes for one revolution, right? Distance is 2 pi r, the time is the period, and so I can then replace this with 4 pi squared r over 1 over f squared. Because period is 1 over frequency, we can plug 1 over frequency in here for my time, and now that's squared. And again, our math teacher doesn't like fractions within a fraction. This is just algebra. It becomes 1 over f squared, and instead of dividing by a fraction, we're simply going to multiply by the reciprocal. So now it's f squared over 1, that's my reciprocal, and we get that the acceleration centripetal is 4 pi squared r frequency squared. So this is how we would plug this in if we're given the frequency. Not something I would assume that we would see, but I think it's just good practice as we're working through a problem without any numbers and being able to just do the algebra to follow along with the concepts.